let's put our knowledge of integration rules to the test and work some actual explicit integrals. So in the first case, I have 5 minus x dx. So to do that, what I have is I have some function plus another or minus another function. So what we do is we take the antiderivatives separately. We say the antiderivative of 5 is 5x, because that's that constant rule. The antiderivative, this is like x to the 1, so we add 1 to the power and divide by the new power, x squared over 2. And then we don't forget our arbitrary constant. Okay. Our next one is the same type of process. We have x to the power, so that's to the 3 halves. So we add 1 to the power and divide by the new power. So that new power is 5 halves. The same thing is true here. We add 1 to the power, divide by the new power. This one doesn't have a power, it's just a constant. So we add an x to it. And then we can simplify this. We can take the reciprocal here and we get 2/5 x to the 5 halves plus 5x squared plus 2x plus c. Now for the next piece, we need to rewrite this with powers that make sense. So I'm going to rewrite this as x to the 1/2 plus 1/6 x to the negative 1/2 dx. Right? Because that square root of x is to the 1/2, but it's in the denominator, so it's a negative power. So then we do the same thing here. We add 1 to the power. We do the same thing for this one. We add 1 to the power. Since it was negative 1/2, it becomes 1/2. And 6 was already on bottom, so then we divide by 1/2, which is the same as multiplying by 1/2 on bottom, plus c. So that gives me 2/3 x to the 3 halves plus 1/3 x to the 1/2 plus c. So that one may be a little bit tricky, but try differentiating it. If you take the derivative, the 3 halves will cancel with the 2/3. We'll subtract 1 from the power, that leaves us x to the 1/2. In this case, the 1/2 comes down, that gives us 1/6. We subtract 1 from the power, that gives us a negative 1/2. That gets us there, and the derivative of the plus c is 0. So moving along, now we have this one. Now we have a constant, so we could pull this thing out. We could say that this is really 3 times the integral of cosine x dx plus 8 times the integral of sine of x dx. Right? Those are our, not only our sum rule, but that is our constant multiple rule as well. Now we know that the antiderivative of cosine is positive sine. So this is positive sine of x. And we know that and so you might ask yourself a very important question. If this is a plus c here, and the antiderivative of sine is negative cosine, and this is like a plus c here, how does that work? Well, what ends up actually happening is that each one of these is some random number. And because of that, those are treated separately, but since this is some random number and this is some random number, together they still form some random number. So your actual answer is 3 sine of x minus 8 cosine of x plus c. Hopefully that makes sense. At the end of the day, you always have just one arbitrary constant when you're dealing with these types of integrals. There are other integrals where you end up with multiple constants, but we're not dealing with that right now. Now in this one, the key is going to be rewriting this denominator, or rewriting this fraction. So what we can do is we can say that that's x over the square root of x plus 4 over the square root of x dx. And then what we can do is we can rewrite those as powers. We can say that's going to be x to the 1/2 plus 4x to the negative 1/2 dx. So then we use the power rule separately on each one of these. We add 1 to the power and divide by that power. We add 1 to the power and divide by that power. And then when we rewrite this, we get 3/2 x to the, wait, that should have been 3/2. So this should be 2/3 x to the 3/2 plus 8 x to the 1/2 plus c. This one's a little more tricky to check because when you take its derivative, you're going to get this, not this or that. So you're going to need to have decent algebra skills to make sure that you're actually handling this appropriately. But finally, we have this one. So I have a theta to the 5th, but I have a secant squared of theta. So I have a trig function and then just some random theta. Well, in that particular case, what we're going to do is we're going to treat the theta here with the power rule. We're going to say, oh, well, that's just theta to the 6 over 6. That's it. It's just a standard power rule. But the antiderivative of secant squared x is tangent of theta. Or, sorry, secant squared theta is tangent of theta. And then don't forget your arbitrary constant. And that one's actually surprisingly easy, but it tends to throw students off because it's mixing what looks like a polynomial term and a trig term. And it is mixing those things. But for some reason, those thetas, students don't like to see thetas like in the wild, not attached to trig functions. It makes them uncomfortable.